Antrhopic just released Claude Opus 4.6. This comes after, I think, approximately 2 or 3 weeks of speculation regarding is Sonnet 5 going to be released, how come the Opus 4.5 performance seems to be downgraded, etc., etc. A lot of buzz in the world, especially people who use Claude Code were very frustrated from Opus 4.5 in the recent weeks, and now out of the blue 4.6 is released, and it was released, I guess, just 30 minutes ago. And I want to share with you the gist of the announcement. I've read the announcement quite a few times in order to understand exactly what was released. I also briefly went over the system card. It's 212 pages, so obviously didn't have time for reading everything. If you're more interested in the technical nitty-gritty, I always recommend checking out the system card. But for now, let's cover the most exciting stuff based on my perspective. Some of you might find this, I'm going to skip a few things, such as Claude Co-work, stuff like this that I don't care about. But let's cover the gist. Let's start with the benchmarks. Basically, it seems like Opus 4.6 is crushing the competitors on almost all the benchmarks. So this is the knowledge work benchmark. You can see over here 4.6, the improvement in opposing to 4.5. And over here we have GPT 5.2. I'm not even talking about Gemini 3 Pro. Also in agentic search, in coding, and also in reasoning. You can see overall across the board significant improvements. Over here we also have like a table that breaks down different benchmarks and the performance of 4.6 versus other leading models. So 4.6 over here, 4.5 Sonnet, Gemini, and GPT 5.2. I'm not going to go over everything. Let's just go over the stuff that is interesting. So first of all, a common complaint about AI models is context rot, which is basically when you have when the context window is being used significantly. Let's say after 50% of usage of the context window, the quality of responses starts to degrade. This is called context rot, and many people are using different types of mechanisms in order to compact the context, or just spin new sub-agents, or just start new tasks very often with fresh context in order to preserve the quality of the output. So basically over here they're saying that Opus 4.6 performs way better than 4.5 in different types of tests or evaluations. They also extended the context window. I want to show you in a moment. Over here a few more benchmarks, so long context retrieval, long context reasoning. By the way, you can see over here they have the 256K context window and also the 1 billion tokens window. As you can see, while the context window is larger, the performance is actually not as good, which makes sense because if it's a larger context window, obviously there might be a degradation in results. Over here, a few more charts regarding software related stuff. So root cause analysis, multilingual coding, long-term coherence, cybersecurity, and life science. Safety, I don't really care about. I mean, I do care about safety, but let's skip it for now. Okay, so these are the most interesting stuff in my opinion. So Claude Developer Platform, some of it is API, but in general it shows you the directions that Antrhopic is taking. So first of all, we have adaptive thinking. So previously, developers only had a binary choice between enabling or disabling extended thinking. This is in the API. Now with adaptive thinking, Claude can decide when deeper reasoning would be helpful and at a default effort level, which is kind of related. We will discuss effort in a moment. And the model basically uses extended thinking when it deems it to be useful, and developers can adjust the effort level whenever they feel like. Now, effort basically we have 4 different levels to choose from. So we have low, medium, high, which is the default one, and max. And basically what they are saying that you should experiment with different levels. Now let me show you a breakdown of the differences between these two, because initially I was a bit confused. Now before I move on, let me just tell you that I'm keeping the most interesting part and the most interesting demonstration to the end of the video. We will cover this in just a few minutes. But for now, adaptive thinking, what it is, it's a mode for extended thinking, the internal reasoning / chain of thought Claude does before answering. It's specific to Opus 4.6 only. And the problem it solves, as we said, is previously you had to manually set budget tokens, a fixed number of thinking tokens, too low and Claude couldn't reason deeply enough, and too high and you wasted tokens on simple questions. Now how this works, so you set thinking to be adaptive in the API, and Claude decides on its own whether to think and how much based on the complexity of the question. So now effort, what is an effort? Effort is basically a knob or a parameter that you can play with in order to tell Claude how much tokens you would like him to invest in this round. So basically, let me read this. A separate parameter that controls all token spending, not just the thinking, but also text responses, tool calls, and explanations. It works on Opus 4.5 and 4.6, and the levels, as mentioned, are low, medium, high, and max. Now what it affects the response and the detail in the response, the number of tool calls made, whether Claude explains its plan before acting, and how much thinking happens. And here's like a table of the differences, which we will skip. And what they are saying is the recommended Opus 4.6 setup is to combine both, having the adaptive thinking and then deciding which effort level you would like. So basically, adaptive thinking, you decide whether to think on how much to think. You're saying this to Claude, and the effort is here's how hard you should try overall. Now here are a few scenarios. So chatbot answering what's 2.2. So it's not such a complex problem. So if it's on adaptive setting plus low effort, it's going to skip the thinking phase, and it's going to return 4 faster or in a shorter response. While if you told it to be adaptive plus high effort, so Claude sees it's trivial, so it skips the thinking entirely and it returns 4. And in a different scenario over here, which is more complex, if you have the adaptive thinking and the high effort, Claude is going to think deeply, write a thorough multi-paragraph explanation, while if you have the adaptive thinking and low effort, Claude still thinks because it is hard, but he thinks less and gives a shorter answer and maybe skips some nuance. So the takeaway is effort is the volume knob, even on harder problems. Low effort means don't go overboard. So this is kind of a summary regarding effort and the new adaptive thinking capability. They have released a beta feature, which is context compactation. It's mainly for long-running conversations and agentic tasks via API. I'm using mostly Claude Code, so I'm going to skip this, and I'm operating under the assumption that you guys are using mostly Claude Code as well. 1 million token context. So Opus 4.6 is the first Opus class model with 1 million token context. They discussed the pricing, which isn't cheap, but we are used to that already. What else? US only inference. So for workloads that need to run in the US, you can pay more in order to have US only inference. Not so interesting in my opinion, but obviously it's just not my use case. And now this is the most exciting part, and I skipped a few things that are not so exciting, and this is presenting agentic team. So basically, from now on, within Claude Code, you can orchestrate teams of Claude Code, which basically means that you can coordinate multiple Claude Code instances working together as a team with shared tasks and inter-agent messaging and centralized management. Now, unlike sub-agents, which run within a single session and can only report back to the main agent. We can also interact with individual teammates directly without going through the lead. So here's a covered documentation, long and comprehensive documentation regarding how does this work. Let's cover this briefly, and then I will show you. It's pretty amazing. It just opens many Tmax panes and just starts a conversation between different agents. We will see that in a moment, but let's just cover this. So agent teams are most effective for tasks where parallel exploration has real value, and there are use cases examples below. Research and review, so multiple teammates can investigate different aspects of a problem simultaneously, then share and challenge each other's findings. New modules or features, so teammates can each own a separate piece without stepping on each other. So this is very important because it has baked in like a layer of coordination that you don't need to necessarily open different Git trees in order to make sure that you're not overriding different efforts while you're building in parallel. Another use case is debugging with competing hypotheses. So teammates test different theories in parallel and converge on the answer faster, etc., etc. Now, here's a very important comparison between sub-agents and the agent teams. So let me make this even bigger. Okay. So this is the context. This is how it looks like with sub-agents, and this is how it looks like in the agent teams. So first of all, in terms of the context, where in sub-agent, we own the context window, results returned to the caller. So this is like the main agent. In agent teams, there is fully independent context windows. So the agents are just going to open new Tmux panes and run over there. In terms of communication, reports flow back to the main agent only. In the agent team, teammates message each other directly. In terms of coordination, so main agent manages all work. Over here, we have a shared task list with self-coordination. Use cases in which it's best for, so sub-agents are mostly for focused tasks where only the results matter, and agent teams are for complex work that requires discussion and collaboration. Obviously, it goes without saying that sub-agents are more tokens friendly, because results are summarized back to the main context, while the agentic teams require more tokens because each teammate is a separate Claude instance. Now, in terms of enabling the agent team, you just go to Claude Code, drop this link, tell it, listen, I need your help with implementing agent teams, and it's just going to start to add this to your JSON, and it's going to, you will be able to start doing this. In terms of control, you will see in a moment how it looks like. This is a very detailed explanation and documentation regarding what you can do, how you can shut down different teammates, how you can clean up different teammates, how exactly does it work, the architecture, which is important. So let's cover this. An agent team consists of the team lead, the main Claude Code session that creates the team, spawns the teammates and coordination work, teammates, which are separate Claude Code instances that each work on assigned task. And this is stuff that I try to do on my own, but just using a Claude Code instance to spin a new Tmux pane and control what is going on over there. So this was artificial and not necessarily, it was a workaround, but now this is officially published by the Claude Code team. There is a task list, which is a shared list of work items between the teammates share. And which is new, there is a mailbox, which is a messaging system for communication between the agent. This is like regarding permissions, context and communication. Let me see if there's anything else that I want to cover. Yeah, let's just cover the limitations because this is important, obviously. So no session resumption with in-process teammates. So resume/rewind do not restore in-process teammates. After resuming a session, the lead may attempt to message teammates that no longer exist. If this happens, tell the lead to spawn new teammates. Task status can lag, so teammates sometimes fail to mark tasks as completed, which blocks independent tasks. If a task appears to be stuck, check whether the work is actually done and update the task status manually, or tell the lead to nudge the teammate. Shutdown can be slow, one team per session, and a lead can only manage one team at a time. Clean up the current team before starting a new one. No nested teams, so teammates cannot spawn their own teams or teammates. Only the lead can manage the team. And the lead is fixed. The session that creates the team is the lead for its lifetime. You cannot promote a teammate to lead or transfer leadership, which, okay, is fine. Permission is being set at the spawn. So all teammates start with the lead's permission mode. You can change individual teammates mode after spawning, but you can't set per teammate modes at spawn time. And split panes require teamworks or item 2. Let me show you an example of how this looks like. Okay. Please create. Why am I typing? Please create a new agentic team for me. I want this team to research different AI-related newsletters and find sponsorship position in these newsletters. So this is the process. In a moment it will start just opening multiple panes. Hopefully it won't crash. It's taking a look, because I have a skill that has a research focus, so I hope that it won't. Let's see what it does. I'm not sure why it opens this skill. This is interesting because it's creating a skill which I never requested it to create. This is one of the risks in which you do like a demo live without knowing exactly what you want to do. But this is what I like doing, and I tested before, and it did speed up a team. Let's do something else in the meanwhile. Let's take this specific page and let's tell Claude to spin a team based on this. Here's the context. Spin a new team. Wanna research different AI newsletters and sponsorship opportunities. Let's see what it does. Okay, we just built a skill over here. So it's probably maybe because I was using voice typing and didn't understand. I wanted a new agent team because it figured that I wanted a team. So maybe it's all about my accent. Let's pause this for a second. I meant creating an agentic team. Let's see what it does over here. So team created. Now let me set up the task and spawn researchers. Okay, this is, I think it understands over here. It's funny that it didn't trigger. Okay, here you go. So we have the newsletters scout. We have the marketplace researcher, and see how it opened a new teamworks pane. Let's give him the permissions. Now it opens, what does it do? It opened this instance, ROI analyst, another instance which is trying to spin. Let's see what it does. And in teamworks, I configured teamworks with this menu, which allows me to zoom into sessions. Let's zoom out. Doesn't seem to be doing anything at the moment. Let's zoom into this one. Let's allow him to have the permissions. And I'm guessing that, let's zoom in over here. This is the most interesting part at the moment. Okay. So team created. Now let's set up the dependency. Sponsorship pricing depends on knowing which newsletter exists and spawn the researchers. Team is live with 3 researchers working in parallel. Teammates newsletter scout, and he has the task. Teammate marketplace researcher, and he has a task. The focus is evaluating ad platforms. We have a teammate called ROI analyst, which has task number 8, focus sponsorship, ROI benchmark, CTR data, case studies, best practices, etc., etc. I let them work and report back as findings come in. Use shift up down to pick at the teammates directly. Let's zoom out over here and see what's going on. It doesn't seem like anyone is doing anything, but let's see. Are they working at the moment? Because I don't see anything in the actual team workspace. I believe that they are working behind the scene, but I don't see anything over here. Maybe this is one of the lags that they meant. This is an interesting. It's interesting to understand the mechanism, whether they are working underneath the hood or not. It's checking. They are spawned by setting a deal at the welcome screen. The prompts didn't get delivered as messages. Let me kick them off directly. Okay, that makes more sense. Messages delivered to all 3 teammates inboxes. They should wake up and start working now. You should see activity in panes 18, 19, and 20. These are the panes. Check them with shift up to cycle through teammates, or just look at the teamworks panes directly. I'll wait for the results to come back in. Nothing happening over here. Nothing happening. Might be related to my setup, I don't know. Let's see. Okay, there you go. Okay, there you go. Research and catalog the top 20 AI machine learning newsletters. Research newsletter sponsorship ROI benchmarks. Research newsletter advertising platforms, etc., etc. So, as you can see, it's just as if I was operating in more teamworks panes with Claude Code. So we just have the orchestrator or the team lead speaking with the teammates, and I can also speak directly with the teammates because these are basically Claude Code instances. I guess we will start concluding now because there's no point in me showing you the whole process. I want to study it on my own because, as I said, this was only published an hour ago, but I just wanted to show you, like, summarize this announcement and this release from my perspective, what is impactful and what isn't impactful. I'm going to research this. I'm probably going to release another video tomorrow about my findings. I hope you enjoyed this video in the meanwhile. Obviously, if you haven't already, go check out Opus 4.6 and start vibing with it and see if it's significantly better than 4.5. If you enjoyed this video, obviously like and subscribe. And until next time, keep on automating.